In this video, I am going to discuss about Charles Hubbard Judd's theory of transfer of learning. Judd's water jar experiment. Charles Hubbard Judd conducted a notable experiment in the early 20th century to investigate the transfer of learning. His research focused on how training in one area could affect performance in another, specifically examining the principles underlying such transfer. Here is a detailed discussion of Judd's experiment. Judd aimed to understand how learning general principles rather than specific tasks could influence the ability to apply knowledge to new situations. He was particularly interested in how cognitive understanding, that is, knowledge of underlying principles, affects the transfer of learning. Judd's experiment involved two groups of students and a task that required them to shoot at a target underwater. The task was chosen because it involved a basic physical principles, the refraction of light when it passes from air to water, which causes the target to appear in a different position than it actually is. Now the experimental setup. A target was placed at the bottom of a tank filled with water. Participants were instructed to shoot at the target with a small arrow. Now among the two groups, first group is control group. This group received no specific instruction about the refraction of light. They practiced shooting at the target without any additional information about why the target appeared displaced. The experimental group. This group was taught the principle of light refraction. They were informed that the light bends when it moves from air to water, making the target appear higher than it actually is. They were instructed to aim lower than the apparent position of the target. Now, results. The control group, which did not receive any instruction about light refraction, showed less improvement in their shooting accuracy. Their practice attempts resulted in trial and error learning, but they did not systematically improve in aiming correctly. The experimental group, which was taught the principle of refraction, showed a significant improvement in their shooting accuracy. They were able to apply the learned principle of refraction to adjust their aim correctly. Judd's experiment demonstrated that underlying general principles enhance the ability to transfer learning to new and similar tasks. The experimental group, armed with the knowledge of refraction, could apply this understanding to improve their accuracy, whereas the control group could not make the same adjustment without the conceptual understanding. Now, transfer of learning. Transfer of learning refers to the process by which knowledge or skills acquired in one context are applied to another context. It is a fundamental concept in educational psychology because it determines how effectively individuals can use what they have learned in new and varied situations. Now, definition. According to Perkins and Solomon, transfer of learning is the ability to extend what has been learned in one context to new context. According to Sorenson, a person learns through transfer to the extent that the abilities acquired in one situation help in another. Now, types of transfer. Based on direction, there are basically two types of transfer, that is positive transfer and negative transfer. Positive transfer occurs when learning in one context enhances performance in another context. For example, understanding mathematical principles can improve problem-solving skills in physics. Negative transfer occurs when learning in one context hinders performance in another context. For example, a person who learns to drive on the right side of the road may struggle when driving in country where driving is on the left. Now, based on nature, there are vertical transfer and horizontal transfer. Vertical transfer occurs when previous learning is essential for new learning. For example, learning arithmetic is essential before one can learn algebra. Horizontal or lateral transfer occurs when learning in one area influences learning in another area at the same level of complexity. For example, skills in playing the piano can facilitate learning to play another musical instrument like the guitar. Based on the degree of original and new learning context, there are two types of transfer, that is near transfer and far transfer. Near transfer occurs when there is a close resemblance between the original learning context and the new context. For example, using the knowledge of driving a car to drive a truck. Hard transfer occurs when there is a significant difference between the original learning context and the new context. For example, applying principle learned in physics to solve problem in economics. Based on specificity, there are two types of transfer, that is specific transfer and general transfer. Specific transfer involves applying learned skill to very similar situation. For example, using a learned formula to solve a similar mathematical problem. General transfer involves applying general principles or strategies to different situations. For example, using critical thinking skills learned in history to analyze a political scenario. Now, educational implications. Teachers should focus on teaching general principles and concepts rather than rote memorization of facts. This helps students apply what they learn to a variety of contexts. For example, teaching the scientific method as a general problem-solving strategy can be applied in various scientific disciplines, developing higher-order thinking skills. Educators should encourage the development of higher-order thinking skills such as analysis, synthesis, and evaluation. These skills are essential for the effective transfer of learning. Activities that promote critical thinking and problem solving should be integrated into the curriculum. Use of varied teaching methods. Teaching methods should be varied to provide students with multiple contexts in which they can apply what they have learned. This could involve project-based learning, case studies, and real-world problem solving. For instance, integrating cross-disciplinary projects where students apply mathematical principles to solve engineering problems. Encouraging metacognition. Students should be taught metacognitive strategies to help them become aware of their own learning process and how they can apply what they have learned in different situations. Educators can encourage students to reflect on their learning and think about how they can use their knowledge and skills in new contexts. Focus on lifelong learning. The education system should emphasize the importance of lifelong learning. As students encounter new situations throughout their lives, the ability to transfer learning becomes increasingly critical. Curriculum design should include skills and knowledge that are broadly applicable and adaptable to changing circumstances and new challenges. Charles Hubbard Judd's theory of transfer of learning highlights the importance of understanding and applying general principles across various contexts. The types of transfer, that is positive, negative, vertical, horizontal, near, far, specific, and general, provide a framework for understanding how learning can be applied in new situations. The educational implications underscore the need for teaching strategies that promote the transfer of learning through a focus on general principles, higher order thinking skills, varied teaching methods, metacognition, and lifelong learning. Now try this.